we're going to look at how to do an arithmetic sequence, and they're pretty similar to linear functions, which we already did in Unit 2. So the one difference is that when we're doing an arithmetic sequence, the numbers that we use are only counting numbers, whereas linear functions use all numbers, whether they're decimals or whole numbers. So we're going to look at exercise 1 as an example to illustrate that. And it says Evan's saving money. She has $12 in her account, and she gets an allowance of $4 per week and plans to save $3. So you'll see that each of the numbers, the n values, represent how many weeks have gone by, and then a of n represents the amount of money in her account. So by increasing each of these by 3, we can fill in the rest of the table, because that's how much she's saving every month. They also want us to write a recursive definition for part B. So remember, with recursive, you need to have the first number. So in this case, a of 1 will be 15. So after 1 week, we have $15 saved. And then each next number is going to be the last number plus 3 more. So the first one shows our starting amount for our first value. We start at 15 for 1, and the second one shows the change for each one. Now the graph of this sequence is incorrect because there shouldn't be any line connecting the points. So this should only have points because there's no other point where she's receiving money for that week. So remember, there's no decimals involved with this. So in the case of a linear function, if it was a linear function, it would be connected, but since it's a sequence, it would only have those values that we had. So realistically, it would just be those points only. Now, they proposed an explicit formula, which is very similar to a linear function of 3n plus 15, and they say to test it. So if we do plug in 1 for n, it's wrong because we get 18. Now the one that would be correct, which would contain the slope and the y-intercept similar to a linear function, would be a of n equals 3n plus 12. Because if there was a 0 involved, it'd be 3 less than that first value, 15. So this would be the correct explicit formula. And again, you want to make sure to test it by plugging in or checking a table that'll go with that. Now if we go on to exercise 2, we're talking about an arithmetic sequence. They give us a recursive function. They want us to find the fourth term in the function. So we know the first one's -3. That's our first term. And they want us to add 6 to get the next one. So then we're going to have 3 if we add 6, 9, and then we'll have 15 for the fourth one. And again, the sequence again is just a list of numbers. Now another part that we're going to do together is exercise 3. And they want us to determine if it's an arithmetic sequence based on the information. So, like it says earlier on, arithmetic has to be increasing or decreasing by the same amount. So, we need to determine if the increase from one term to the next is the same for every successive term after that. So like in this case, if I go from 5 to 9, I'm adding 4. 9 to 13, I'm adding 4. 21 to 25, I'm adding 4. So in this case, I would have to put 17 here. So this one is arithmetic. Now for B, if I add 5 to get from 5 to 10, but then I add 10 to get from 10 to 20, so B is a no. C, looks like I'm going down by 3 each time. So in this case, this number would be -2, which this is arithmetic. It could be increasing or decreasing. And the last one, we're going down. So we're going down by 48, and we're going down by 12. Well, in that case, this one's going to be a no as well. And we'll talk about B and D in the next assignment, because these are going to be what are called geometric sequences. Now, the last one we're going to look at is exercise 4. And we got a sequence, and they gave us the first three terms. They say the first three terms are 4, 14, and 24. So they're kind of helping us develop a formula for this. The fourth term is going to be 34. And then the second part of the question they ask, how many times was 10 added to 4 to get to the fourth term? Well, in this case, to illustrate this, they said draw it out. So we added 10 3 times. Now they want us to use what we learned in part A to find the 10th term. So to get the fourth term, we added 10 3 times, which would be 3 times 10. To get the 10th term, we've added 10 9 times, which would be 9 times 10. So in this case, the 10th term, to get that 10th term, it'll be, in this case, the first term, which is, in this case, 4, plus, again, we're going to do 9 tenths. So the 10th term for this is going to be 94. So the formula for this would be A10, or AN, equals the first term plus n minus 1 times the difference. So in this case, the difference would have been 10. Now they want us to write a recursive formula. Well, in this case, the first term is 4, and then each next term is going to be 10 plus the last one. So this would be n minus 1 plus 10. And an explicit formula for this, again, you might be thinking that it's going to be 10n plus, I'm going to write this even though it's wrong. Some people are thinking, okay, it's going to be 10n plus 4. But if you put 1 in, you get 10 times 1 plus 4, which is 14, which is the second. So you have to subtract 10 from that last number, the 4. So this one's incorrect. The one that would be correct, and you want to check it, for this, a of n is going to equal 10n minus 6. And again, in that case, if we put 1 in, we're going to have 10 times 1 minus 6. Oops. Let me erase that. 10 times 1 minus 6, which in that case would be 4, which is the same as the first term that we had. So don't get tricked up with that explicit formula. If you see it, make sure you test it after you come up with it. Same thing even with recursive formula. Those are a little more to write out once you get the idea. But again, when we're talking about arithmetic, you're talking about a sequence that's going to increase or decrease by the same number.